Maybe, maybe not. So let's review this. Decimals and rounding. Okay, so let's look at the following number. 2,139.4508. So my first review that I think maybe the terminology or vocabulary. This is the 10th spot. This is the 100th.
Professor, we can't see your screen.
Uh-oh.
You can? Oh, I thought.
So unpin the video so you can see exactly on the entire screen. You should see what I'm writing. Can you?
No, you said unpin the video.
Yeah, so double click on my video. Can you double click on it?
Yes, I'm double clicking.
And make sure that it's not pinned, or if you want to pin it or something is. This should be.
Okay, I have it.
Okay, very good. Everyone else okay? My pleasure. Everyone else okay? Everyone? Tyler, I can't see you. Are you there? Did you go swimming, Tyler? I guess Tyler went swimming. Okay, hundreds. Well, Tyler is here. Wonderful. Thank you. Thousandth. And 10,000. So let's say we want to round this number. Let's round it to the nearest, so round the first example. Round it to the nearest thousandth. What will you say? Tenths, hundreds, thousandths, and this is a number greater than 5, which means I have to add 1 to the thousandth. So the number becomes 2139.451. I rounded to the thousandths. And then number 2 option. What if I want to round to the 10th, to the nearest 10th? Round. Stop me if you have questions, please. To the nearest 10th.
Sorry, I do have a question.
Please.
I see that it's 0.451, but it's, and I assume it's because it was a 9, and the 9 is becoming a 10, which is why it's a 1 now?
So this is a 0, it's not a 9.
Oh, okay, thank you.
No problem, sorry about that. So this is a 0, so from 0 I go up 1 because this is larger than 5.
Okay,
So
yeah,
then,
sorry, I thought it was a 9.
no worries, no
0,
worries,
it makes total
no
sense.
worries. Is it blurry? Do you think it's blurry? Do I have to do something to make it clear?
No, it's just that the arrow line from the thousandths extends down off the...
I'm sorry about that. Yes.
Sorry, I was my mistake.
No worries. So 2139.4508. Now I want to round to the nearest 10th. How do I do that? Can anyone give us the number?
It'll be 2139.5.
That's it. Very good. Okay, so now we're ready to work on the intro to the practice of statistics. I have a couple of minute quiz for you. It's already there if you want to click in Canvas. Let me make sure that if you click on home, can you click on home for me?
Do we have to do that if we have a physical copy?
No, 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 no. No, that's why I want to make sure that we understand what we need to do. So please go to Home in Canvas and tell me whether in the right column you see decimals and rounding, and if you can click on it. Just to make sure there are no other glitches.
Yes, you can.
Very good. Everyone, can we click on that?
I can click on it.
Very good. So let's quickly answer those two questions. Let me know if you need help. Anything?
Wait, what was it that we were clicking on?
Okay, so go to Home. Can you click on Home?
Yeah.
In the right column, you should see decimals and rounding. Do you see that? Can you click on that?
Oh, yeah, okay.
It says 2 points. Another way would be to go in through grades. And let's see, is everyone in? Is everyone working
Yes.
on it? Now, if you happen in the future, if you happen to enter something that is not exactly the way I entered it, you will get your point. So don't worry about it. In this case, it shouldn't be any problem, but it's good to check all the technology, make sure there is no glitch.
Professor,
Yes, please?
I submitted an answer as 239.0, and it says it's incorrect. The answer is 239, when clearly it's the same thing.
Yeah, the same problem. Yeah, me too.
Remember, 1 minute ago I said that if you enter the answer in a different way that I did, you will get your point if it's correct. Did you hear me say that? Or you're focusing on the quiz? I would look at it, and if it's the same thing, even if you entered it in a different way, you will get the point. Is that okay with everyone?
I'm also confused.
Okay.
Okay, you said to go home, so I was zooming Canvas, and then I went home, the home part. But also I have the papers that I was supposed to print out, so I'm just confused.
This is a quiz we are talking about. We're not talking about the handout.
We're not talking about
It's
the handout.
different.
Yeah, okay. So how do I get there from home?
In the right column,
Yeah.
you have to click on decimals and rounding. If you don't see it, go through grades, and then you will see decimals and rounding.
Okay, yeah, I got it. Thank you.
Very good. Anyone else? That's why we needed to do this, just to make sure if there is any glitch that I need to correct or something is not right. I will look at the quiz and I will give the points if the correct answer was entered, but just in a different form. So there is no need to write 123.0. It's the same. It's not a mistake. It's an example. So 123.0 is the same with 123. If you enter this, you get the point. If you enter this, you get the point. Is that clear? I mean, was that the question, or did I misunderstand something?
That's perfect.
Okay, very good. Do we need more time, or can we continue now?
Let's continue.
Very good. Okay, so intro to the practice of statistics. This is chapter 1. And let's first of all define what statistics is made of. What are we trying to do when we talk about statistics? What's behind it? When we say algebra, we know, we add, we subtract, we so on and so forth. Well, what about statistics? We are basically interested in variability. Interested to study variability. If something is that causes if we can find out what causes variability, or if we may have an idea, we want to test whether that is the case. So we are collect data, summarize data, and analyze it. So we collect, we summarize, and we analyze the data. That's what statistics is all about. We have to have the data. Once we have it, we summarize it, and after we summarize it, we analyze it when we draw conclusions. We're going to look at two different types of statistics. Tell me at any point in time if I'm not centered, if something is not clear, keep me on the right track, please. And I'll try to do the same. So we have two different types of statistics. Descriptive and inferential. Inferential. Descriptive, inferential. Okay, so descriptive is basically going to be chapter 1 through 6. And this is 7 through 12. So in descriptive, we are going to organize, summarize the information. And in inferential, we're going to draw conclusions. So descriptive is collecting the data, summarizing, analyzing the data. And this is basically when we draw conclusions. Okay. Any questions so far? Now, we're really interested in drawing conclusions about a population. Population is our target. But when I say population, well, I don't really mean necessarily people. It can be rats, it can be rabbits, it can be just anything. So a population refers to a target, our target, what we're interested in drawing conclusions about. It can be people or it can be anything else. We cannot collect information on everything, all the entire population, most of the time. If you say, well, if the population that I'm talking about is AACC students, we're not talking about millions, and I can create a study and study the entire population of AACC students. That's not going to be a big deal. That's fine. But if we're talking about big populations, we will not be able to collect. We're not going to be able to do a census like we're doing this year on everyone. If we're not able to, then we're going to look at a sample. We are going to collect a sample to study and draw conclusions about the big picture, about the population. For many reasons. This is very costly. But if I can create or determine a sample that is representative of the population, I'm not going to go in front of Walmart and ask people if they like hot weather or cold weather. That's not a sample that represents the population. Or in any other store or any other place. It's a convenient sample. If I create, and we have schemes, specific schemes, that create samples from a population that are representative of the population, then when I draw conclusions from this sample about the population, then they make sense. I cannot just say, I created a sample, I have to make sure that I give the information on how I created the sample, and there is no bias in the sample, or very, very little, because zero bias is really, really not possible. But I have to present the scheme. Now, this is the first thing that we should establish from the very beginning. The population size is denoted by uppercase N. Sample size is denoted by lowercase n. We have what is called data of two different types. Categorical, also called qualitative. So we can collect on anyone we want, like let's say any particular interest we may have. Let's say we want to study hair color, for example. Categorical, qualitative, hair color. That is qualitative or categorical. We use these interchangeably. They mean the same thing. Categorical or qualitative. Can anyone give me another example of a categorical or qualitative data other than hair color?
Gender.
Very good. Excellent. Which one? Eye color. Very good. Excellent. The other type of data is quantitative. They are numbers, and I can use them in calculations. So can anyone give us any quantitative?
Age.
Excellent. Height. Weight. These are quantitative. The qualitative data can be of two types. So qualitative type, ordinal. I can present them in an order, like grades. I can present grades in an order. And the other possibility is nominal. I cannot order them. No order is possible. Like gender, like eye color, hair color. Quantitative data is also of two types. Let me know if you can keep up. Let me know if you need more time.
What do those two words say? Next to the, yeah.
Nominal. N-O-M-I-N-A-L. Ordinal, nominal. Ordinal, I can put them in an order. Nominal, I cannot. Also, quantitative data can be discrete or continuous. Here is the difference between the two, discrete or continuous. I cannot say that I have 1.52 cars. So number of cars. Children. Rabbits, etc. I can count them. They are finite. Continuous, and also I should write between 1 and 2. So between 1 and 2. How many real numbers we have? Exactly. But when it comes to discrete, I can only have 1 or 2 I cannot have this number. I cannot have this number. I cannot have this number. Like 1.3.4. I'm sorry, 1.3495. That's not possible for discrete, but it is for continuous. Like they can go from negative infinity to positive infinity. Anything. Any number. Weight, for example. Time. Those are continuous. Okay, so I did print out our handout myself, and I'd like to go through several questions. I'm going to stop my